So we're working on section 7.4, adding and subtracting rational expressions, and I need you to kind of go back to 4th grade to remember what it's like to add and subtract with like denominators, which is really easy. So this is unlike denominators. So let me write one that has like denominators. So let's just pretend that's a 5. Okay, so if you remember, when they have the same denominator, you keep the same denominator, which is going to be 5, right? You don't add them. Then you add the numerators. Oh, look at that. It's going to be 5. And then you simplify when necessary. Everybody remember that? Super easy. Okay, so let's take a look at the polynomials. These are the examples that are in your book. 4x is the denominator, add the top. Now take a look what they did here. So for this example, see how they reduced it? By 2. Divide everything by 2. That's how you got 5 over 2. Same thing here. Now, what you might want to do with the binomials, you might want to keep them like trapped in parentheses. That way you will remember, especially if there's a binomial up here, you'll remember to distribute that negative if you need to. All right, let's do some. Really easy. Same denominator, correct? What's the denominator here? 12x, good. 8 minus 5. 3, last time I checked. Reduce that. 1 over 4x, good job. Okay, over here, same denominator again. So it's going to be 3x squared, add the top. 3, reduce it. 1 over x squared, perfect. Okay, so here we have our binomials. I'm going to keep them together. So 4x minus x. 3x, good. Reduce it. Nothing to reduce, good, because remember you cannot reduce a monomial with a binomial. So you leave it like that. Perfect. All right, over here, what's the denominator? X squared plus 1, good. And this is going to be 2x squared plus 2. Now we're going to roll back to the previous sections, and we're going to factor this. So I'm going to factor out the GCF, which is 2. What's left? X squared plus 1 over x squared plus 1. That is beautiful, because what happens here? These two cancel out, and the answer is 2. Okay, so now we're going to do adding and subtracting rational expressions with unlike denominators. This is big. So notice that C and D are not the same denominator, so you can multiply them together, and you multiply each term to make sure that it has the same denominator. And same thing with subtraction. So let's just go to some problems. Let's move forward to this one. All right, so let's do this one. Okay, the easiest way to find if it has the same denominator, or how to get the same denominator, is to factor it. That's the best way, because it's a little clearer. So look at the denominator of this binomial. What am I factoring out? 3x, right? So what's left is x plus 1. Okay, so I'm going to break this one up too, so that it has my 3x. And what else does it have? It's 3x times 3x, right? That makes 9x. Okay, so let's look to see what's different. So notice what's the same. 3x and 3x. But what's different? The 3x here on this side, and then the x plus 1 on this side. So that means on this side, I have to multiply whatever it's missing. So it's missing here, x plus 1. And then on this side, what's it missing? 3x, good. Top and bottom. Now notice I put the binomial in parentheses to remind you to distribute. I'm going to keep the denominator in factored form just in case that we can cancel it out. So I'll keep it in fully factored form. So it's 3x times 3x times x plus 1. Now let's do the numerator. So this is now, and I am going to distribute this one. I'll show you why, because we have to collect like terms. 7x plus 7 plus 3x squared. Okay? So let's put that in order. 3x squared plus 7x plus 7 over 3x times 3x times x plus 1. So now let me think. Can I factor this? Let's see. I'm going to say no, but I'm going to check. 21 and 7. 3 and 7. Will I get 7? Nope. Cannot factor it. At this point, we're not going to factor it. So that is going to be our final answer. Okay, so let's factor the denominator to see what each of them are missing. So I'm going to factor out a 2 here, x minus 1. And then what am I going to factor out here? Well,
X minus 1.
Good. X minus 1 and x minus 3. Good. And I want to make sure to put parentheses around here. It's important. Okay, so I'm going to do this in blue. What is this missing that this side has?
X minus 3.
X minus 3. And again, I'll put it in parentheses. Okay, so what is this one missing?
2.
Just a 2. So then that means I have to multiply, I have to FOIL this out completely. And I'm also going to multiply this out, but remember there's a subtraction sign here, so this is where it gets kind of tricky. So let's do this first one. I'm going to want to multiply the whole thing out here because you want to collect like terms, and then you'll factor it to see if you cancel anything. So since you guys are great at multiplying this becomes what? X squared minus x minus 6. Good. And I'm just going to leave the denominator fully factored for now, just in case. Okay, that's the whole denominator. Minus, now notice, there's a minus sign there, so I'm going to put brackets here. So distribute that too. This becomes negative 4x minus 2 in the same denominator. Okay, now let's simplify the top. X squared, now look at this minus sign. I'm going to do it in a different color so you see. Do you see how I'm going to distribute that negative to each of these? So this really becomes positive and positive. Right? Negative times a negative makes positive. Okay, so let's collect like terms now. Negative x and positive 4x. What does that make? Positive 3x. Negative 6 and positive 2 makes negative 4. Okay, all over. Again, I'm going to keep it factored. All right, can I factor the numerator here? Good. So what is it? X minus 1, x plus 4. Good. All over 2 times x minus 3 times x minus 1. Great. I get my red pen. What can I cancel out? X minus 1. So that means that my answer is x plus 4 all over 2 times x minus 3. Now, hold on. I'm going to add something here that the juniors didn't get the day that you guys were out. They're called excluded values. Okay? So let's look at the numerator here because it actually makes our asymptote. So what would I add here? What would x be to make this numerator 0? 3. So x cannot be 3. Now look at what I canceled out. Because you can't have 0 in the numerator. Look what I canceled out here. I canceled out the x minus 1. So x can also not be 1. So you have to put the excluded values in. This makes an asymptote, and then this is a hole that's in your graph. This in blue for number 1. Number 6, I mean. So what is this side missing?
4x.
A 4x. And what is this side missing?
7.
A 7. Okay. So I'll do the denominator first. The denominator should be 28x. The numerator, that's going to be 21. I'll put it over here. And this is going to be negative 4x. Good. Plus 21. Now, I already know that I cannot, remember that this is a binomial. I cannot factor out a negative 4 here because just 3 and 7. That means this is the final answer. You can also write it 21 minus 4x, but I don't like that order. Okay, let's do this one. So I already know that I'm going to factor this, so I'm going to go ahead and write this one in factored form. So factored form is going to be 3 times, or let's do, 3x times 3. How about that? Oh, no, 3x times x. My bad. Sorry. 3x times x. Thanks. So this, I'm going to factor this, is going to be 3. And then what comes out? 3, minus 4. Okay. So now we have to look, what is this side? Let's start on this side. Okay, do you see what they have in common? They have a 3, which means, what is this side missing? X squared. Bless you. Okay, now this side. What is this side missing? Yeah, whole thing, whole puppy. 3x squared minus 4 over 3x squared minus 4. Give yourself room, please. This is really 3 times x times x. 3 times x times x. This is 3 times 3x squared minus 4. So they both have in common the 3. Let me circle it so you can see it's in common. So that means that this one is missing an x squared, and this one is missing 3x minus 4. So let's do the whole denominator, and I'm going to keep it in factored form. So this is going to be 3x squared times 3x squared minus 4. There's my whole denominator. The 3 is what they had in common. 3x squared times... No, because this right here, right there, that is the common denominator. This right here is the common denominator. So these two are my common denominators. The 3x squared times 3x squared minus 4. The 3x squared times 3x minus 4. That's the common denominator. Let's finish the numerator. Okay, this is 3x squared minus 4 plus, what's this one? X cubed. Okay, I'm going to write it so that it's in the right order here. So 3x, oh sorry, x cubed plus 3x squared minus 4 over 3x squared times 3x squared minus 4.